30 men were surveyed and their height and weight recorded. A. Are the variables categorical or numerical, and which are the response and explanatory variables? B. Construct a scatter plot. C. Discuss direction, outliers, form of strength, and any association. D. Determine the correlation coefficient R and the coefficient of determination big R squared and discuss. So parts A and B are what you'd expect to see in a simple familiar problem, and C and D complex familiar. Part 2 of this video will also look at manually working out the least squares regression line and the residual plot. Okay, let's talk about part A. Are the variables categorical or numerical, and which are the response and explanatory variables? So we're talking about the variables height and weight. Both are numerical, so we're comparing numerical to numerical, which means that we can do scatter plots. When you're doing scatter plots, it's important to first work out which is your explanatory and response variable. So a person's height is going to have an impact on what their weight is. So as you get taller, obviously you've got more body mass. So height is the explanatory variable and weight is the response variable. Let's do part B. So we're looking at height versus weight. Now, because we've already worked out that the response variable is weight, it must go on the vertical axis, and the explanatory variable height goes on the horizontal axis. I've already set up my tabs to suit counting in tens, but to do this I've gone through the height columns. For height, I've worked out the minimum, which is 166, so I want to start at 160, and the maximum is 208, so the highest height number needs to be 210. So let's go in and put the values in. Now same for my weights. So the lowest value is 68, so we need to start at 60. And the highest is 110, so we can go all the way up to 110, and counting in tens, and that's the scales for your axes. But you just need to make sure that you've got all the numbers that are in the range for both variables. So now we go through each subject. These are all each different people and their heights and weights. So we go through and we plot each point. So the first point is 170 in the horizontal and 85 in the vertical. Second point, 182 and 79. Third point, 186 and 89. Then we've got number 4 is 192 and 85, 196 and 86. I'm just going to keep going through doing exactly the same thing and plotting it. So that's all 30 points plotted. Obviously, because I've done it by eye, it's not going to be as accurate as if I did it with Excel. So you can see a reasonably clear pattern here where the values drift upwards as you go from left to right across the plot. So this means it's a positive association, and the form of the association is of a linear form, so a positive linear form. There's 2 points that stand out from the norm. Now this person here is quite heavy for his height compared to values around this area, and that's the same for this person here. His weights would be expected to be more around this area, so that could be erroneous data. What else it could be is these guys could also be really stocky and muscly for their height, or they could be overweight. So for the remaining data, we're going to eliminate those 2 points from our calculations. Now looking at the strength of the association, the dots are all scattered either side of the line, but you can tell that it forms a line. They're all not really close sitting on the line, so I would call this a moderate association. Okay, for part D, we want to find the correlation coefficient and the coefficient of determination. So this value here is the correlation coefficient, and when you square that multiplied by 100 to turn it into a percent, you get the coefficient of determination. Okay, so we need to set up columns so we can calculate each individual thing, add them up to put the totals in these, and then put them into these equations here. So just looking at the titles for these columns, so we've got height, so that's the list 1 to 30 of the heights. Then we've got x minus x bar. Now in this case the horizontal variable, which is x, is height, because height is the explanatory variable. And so that's just like saying the height minus the mean height, and we put that value in there. Then we've got the weights, which are the values that are recorded, the 30 values. And then we've got y minus y bar, so that's the same as saying weight minus the mean weight, which gets put in there. And then you multiply these two values to put in this column. You square this value to put in this column, and you square this value to put in this column. Now these here are used to find standard deviations, which is this calculation and this calculation, and then they're going to be put into this calculation for R. The first thing we do though before we go ahead is we get rid of any outliers. So we identified that as an outlier and this one as an outlier, so we're not going to include them. So now what we're going to do is we're going to sum up the heights and put it into this column, and that gives 5256. Now just be careful when you're doing a large table like this and using a calculator. It's important as you punch in the numbers to check what's up on the screen. So now we're going to add up the weights, what's in the weights column, and put it here, and that works out to be 2286. So now we've got the information to work out our means x bar. And because we've taken out two outliers, the value for n is now 28 instead of 30. So x bar is sum of x, which is the sum of the heights, 5256, on 28. And that's 187.71. And we'll write it up here as well. So y bar is equal to the sum of the weight, 2286 on 28, equals 81.64, and we'll write it up here. So now we go ahead and work out values across this table. So x minus x bar, so that's your first height value, 170, minus the mean height value. So 170 minus 187.71 is equal to negative 17.71. Then we go ahead to work out this value here, which is the weight in the column minus the mean weight. So 85 minus 81.64 is positive 3.36. Then we multiply this value and this value to put in this position, and that gives negative 59.51. And finally we square this value to put in this position, and we square this value to put in this position. So we've got negative 17.71 squared is positive 313.64, and positive 3.36 squared is positive 11.29. So we'll just do a couple more, and then I'll just fill out the table so I don't bore you to death. Okay, 182 minus the mean height is negative 5.71, and 79 minus the mean weight equals negative 2.64. Then we can multiply those two values to give 15.07, and then we square this value to put here. That gives 32.60, and then squaring this value, that gives 6.97. Okay, last one, hopefully you'll have gotten the hang of it. 186 minus the mean height of 187.71 gives negative 1.71. Then 89 minus the mean weight, 81.64, is 7.36. And multiply those two values, you'll get negative 12.59. Squaring x minus x bar equals negative 1.71 will give you 2.92, and squaring y minus y bar equals 7.36, you get 54.17. So I'm just going to go ahead and continue filling that out until we got the full table and get ready for the next step. Now that's done, we're going to sum the values in this column, this one, and put them there. So you get 1705.14 and 2983.71 and 1870.43. Okay, finally, so we've got to find these values and then input them into this equation to find R. So the standard deviation for height, which is the x value, is just like we did in Units 2 for standard deviation, and it's this equation, so it's the square root of the sum of x minus x bar squared, so that's this value here, so it's 2983.71 divided by n minus 1. Remember, n is now 28 because we removed 2 points, so we're looking at 27 for n minus 1. And that equals 10.51. Now standard deviation now for weight is equal to the square root of all the sum of y minus y bar squared, which is this one. So it's 1870.43 divided by n minus 1, which is 27, equals 8.32. Then calculating SXY, that is equal to the sum of x minus x bar times y minus y bar. So that's this here. So that's 1705.14, all divided by n minus 1, 27, equals 63.15. So now we can work out the correlation coefficient by putting these values into this equation up here. So it's 63.15 divided by 10.51 times 8.32 equals... Now remember, when you put it in the calculator, you should put these in brackets, and that equals 0.72. So what can the correlation coefficient of 0.72 tell us? Now if we have a look over here, these are the rules. So 0.72 lies in this one, moderate positive linear association, which is what we anticipated by looking at the scatter plot. So now we find the coefficient of determination r squared, which is just little r squared times 100 to turn into a percent, equals 0.72 squared times 100 equals 51.84%. So what does this tell us? This tells us that 51.84% of the variation in weight can be explained by the variation in height. So there are other things at play because this value is not a really extremely high value. There's genetics, they might be really working out, they might be overweight, but height is a very important factor in determining someone's weight.